Okay, so the next problem, we have to convert this guy, show that it's a parabola, and state the coordinates of its vertex. Give me 1 sec. I just got to pull it up, the question up on the computer. In polar. Yeah, I thought there was something different there. So I gotta state the coordinates in polar form. Alright, so let's see. I'm gonna start by factoring out a secant. So that's a tan theta plus 2. Secant's really 1 over cosine of theta. So I'll multiply both sides by cosine. I'll probably subtract 2, so I've got r cosine theta minus 2 equals tan theta. R cosine of theta is actually x. So I've got x minus 2 equals y over x. If I multiply both sides by x, I get y equals x squared minus 2x. So I've converted to rectangular. That's a parabola because it's power of 2. State the coordinate of vertex in polar form. First, I would find them in rectangular form, I guess. So the x coordinate is negative b over 2a. That's negative 1, right? That's positive 1, sorry. And then f of 1 gives me 1 minus 2. That's negative 1. So the vertex in rectangular is 1, negative 1. So now for polar, that vertex is over 1 down. It's in quadrant 4. And I've got 1 and 1. So I know that's a 45, 45, 90 rectangle. So I know the hypotenuse of that thing is going to be root 2. So it's going to be root 2. And then that angle right there is going to be negative 45 degrees. So we like to use the positive. So that's going to be a negative pi over 4. So we're going to go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. That's the vertex in polar coordinates. Let me see if I can do the next one as well. Still a 3-minute video. Later.